Here we go, guys. Normal distributions, example 1.10. That sounds funny to say, but anyway, example 1, part 10. All right, so we've got a probability related to the variable z. In statistics, z is the standard normal bell curve with 0 in the middle. All right, just always automatically when you see that variable. And then 3.51 is a positive number, a positive z-score. In other words, in the upper half of the bell curve. And we want to know the probability z is greater than that. So just like on a number line, if you're talking about greater than this number, you're talking about to the right. There you go, that's an upper tail. Now let's think ahead before we go look at the table. When we go look up the 3.51, won't that table give us this area from here to the middle? Let's kind of think ahead this time. So we'll get that middle sliver from the table in a minute. And using the logic we discussed earlier, if that table is going to give us this region, but we want this region, wouldn't we want to take the upper half of the bell curve, 0.5, and subtract that middle sliver to get that upper tail that the question wants? I hope that is working for you all, and I get a good feeling for that. So, 0.5 minus middle sliver, and now it's just a matter of going and getting that middle sliver from the table, isn't it? So once we've got our picture in place, we can come over here and say, all right, here we go. Let's go look at the table. Table time. All right, so anyway. Whew. All right. Now, here's the deal that's different about this question, though. When you go look for 3.51, you'll notice that the largest z-score we get to is 3.09. It's off the table. It's so far out there. Okay, so here's the point of this. See, the bell curve, it tapers off to where once you get to a certain point, it's such a small area, and that's what we're dealing with here. So instead of carrying that table out further, here's the deal. This is what I call a footnote question. It says down here, if you look at the one that you're holding, hopefully, right here, note, use 0.4999 for z values above 3.09. So once you exceed that 3.09, they're basically saying any area beyond that is so small that they're almost all going to be the same the farther you get out. So there you go. That's a footnote question. Use 0.4999 for z values above 3.09. So that middle sliver, 0.4999, think about it. That's almost the entire 0.5, isn't it? There's barely any out there past this, is basically what they're saying. Once you get that many standard deviations away from the mean, that middle sliver is almost the entire 0.5. But anyway, back to the logic that we had earlier. Therefore, we would take that upper half, subtract that middle sliver, 4999, and that upper tail is 0.0001, very small. There's not much area out there above 3.51. So that's basically what that's saying. All right, I hope that worked. Yes.